What is D-Sauty's bridge? D-Sauty's bridge is a bridge which is used to find out the unknown capacitance in the circuit diagram. Okay, today we are going to discuss about modified D-Sauty's bridge. We can measure the capacitance of imperfect capacitor which are have dielectric losses, So before one, in the last class, uh, D-Sauty's bridge, in that circuit diagram only we are measuring the capacitance of perfect capacitor, but the modified D-Sauty's bridge is used for the capacitance of imperfect capacitor, means the capacitor which are having dielectric losses. Okay, here also the same diagram is there, but the components are different. Okay, so this is the AC signal which we are providing to this bridge circuit, but in here also there are four arms are there. Okay, the arm AB, BC, CD and DA. In the arm AB there are two resistor and one capacitor is there, means the unknown capacitance C which is connected in series with the resistor small r1 and capital R1, means which represents the loss of component. R1 is the loss of component and resistor R1. And in the arm AD, the standard capacitor C2 which is connected in series with the resistance R2 and which is representing the loss component and the resistor R2. In the BC arm there is a R3. These are the non-inductive resistance, and this is the non-inductive resistance. And in the arm CD there is one more resistance R4, that is also a non-inductive resistance. Okay, so what are there in arm? First arm AB. In the arm AB, which is unknown capacitance is there. Unknown capacitance C1 which is connected in series with what? Resistance R1, which represents, means this R1 representing the loss component. And another one resistance is there, that is capital R1. Okay, next in the arm AD, this arm AD, the standard here, the capacitor is standard capacitor, which is consisting standard capacitor C2, then which is connected in series with resistance R2, which represents the loss component, and resistance R2. And in the arm this is the and in the arm BC, it is having the resistance R3. In arm CD, the resistance is R4. Okay, and the current which is flowing in the arm AB is I1, AD is I2, in arm BC is I3, then in the arm CD the current is flowing I4, where D is the detector. Okay, D is the detector. The whole energy EMF is E, then the energy in the AB arm is, this is E1, then in the AD arm is E2, then here the energy is E3 and here the energy is E4. This E1 plus E2 equal to E, or E3 plus E4 equal to E. This is the total EMF which is moving through this circuit. Okay, this is the complete is Z1, Z2, Z3 and Z4. Now the value of Z1, Z2, Z3 and Z4 can be given as, the value of Z1, Z2 and Z3 and Z4 are given as, let me show that later. So first Z1 is equal to, first in the arm Z1 is equal to, we can write. So what are the components here? First capacitor is there, then two resistors are there. So this is completely, this we can call it as Z1. So first one is resistor R1, capital R1 and small r1. We can write capacitance of capacitance of capacitor is 1 by j omega C1. Then similarly we can write for the the arm AD, that is Z2. Z2 can be written as R2 plus small r2, that we can write 1 by j omega C2. Then in the Z3 there is only one resistor is there, that is R3, and in the Z4 there is only one resistor is there, that is R4. Now we know that the balance equation is Z1 Z4 is equal to Z2 Z3. Then we are going to substitute the values of Z1 and Z2 in this equation. So let's call this equation as 1, 2, 3, 4, 5. Here substituting the value of Z1 and Z1, Z2, Z3 and Z4 from above equations. Then so that is Z1 is, what is here, R1 plus R1 plus 1 by j omega C1 into Z4. Z4 is equals R4. Then at the right hand side Z2 into Z3 is there. So what is the value of Z2? Z2 value is R2, capital R2 plus small r2 plus 1 by j omega C2. Then Z3 is equal to R3. Then let's simplify this. So let's multiply this inside this bracket, so that we can write as R1 plus R1 into the bracket R4 plus R4 divided by j omega C1, that equals R2 plus R2 into R3 plus R3 divided by j omega C2. So here in this equation, real part is also there, then imaginary part also is there. So what are the real parts and what are the imaginary parts? So this is the real part, j is there, so that's why it is imaginary part. In the right hand side also, the one is real part and another one is imaginary part. Okay, so now equating real part, equating real part. So what we will get? R1 plus R1 into the bracket R4, that equals R2, capital R2 plus small r2 into R3. So R4 by R3, that equals R2 plus small r2 divided by capital R1 plus small r1. Now equating imaginary part. Now equating imaginary part. So what are the imaginary part? R4 divided by j omega C1, that equals R3 divided by j omega C2. So both the sides j omega are there. Let's get cancel them. Here R4 by R3 equals C1 by C2. Call this equation as 6 and this equation as 7. Through this, now equating 6 and 7, equation 6 and 7, we get C1 by C2. We can write that as R4 by R3, also R2 by R2 plus small r2 divided by capital R1 plus small r1, which is the equation of modified D-Sauty's bridge. Through this, we can measure unknown capacitance. What we can calculate? Unknown capacitance C1 in terms of known impedance. In terms of known impedance. Okay, now here another factor will be arise here, that is the another factor is you can calculate, that is dissipation factor. What is that? Dissipation factor. The another factor is dissipation factor. Then what is this dissipation factor? This dissipation factor is it is the tangent of the loss angle. It is the tangent of the loss angle, or we can write this is a reciprocal of quality factor. reciprocal of quality factor. What is dissipation function? It is the tangent of the loss of angle. It is the tangent of loss of the angle, or we can call it as reciprocal of quality factor. Then quality factor is it is the goodness of the electrical component, equipment. It is the goodness of it shows what is the quality factor. It shows the goodness of the electrical equipment. Then dissipation, here what we are calculating, we are calculating dissipation of capacitor C1 and C2. Capacitor C1 and C2. Then dissipation function for the capacitance C1 is D1. So what is the definition? It is the tangent of loss angle. So that we can write as tan del 1. So this we can write as omega C1 R1. Then the capacitor C2 dissipation is D2, that we can write as tan del 2. We can write this as omega C2 into R2. Okay, now we can write, we can substitute the values of C1 and C2. Now let's consider C1 by C2, that equal to R4 by R3, that equals R2 plus small r2 over R1 plus small r1. Now we need C1 by C2, that we can write like this. C1 by C2 equals R2 plus small r2, R1 plus small r1. Now by cross multiplying, we will get C1 into the bracket R1 plus small r1 equals C2 into capital R2 plus small r2. Now C1 R1 plus C1 small r1, C2 R2 plus C2 small r2. Now we will write as this capital R at one side and small r at another side. So C2 R2 minus C1 R1, that equals C1 capital R1 minus C2 capital R2. Now we have to take the difference of this dissipation factors of capacitance, that is T1 and T2. So we have to take D2 minus D1. What is D2 here? Omega C2 omega into C2 into R2. What is D1? Omega C1 R1. Let's substitute. Omega into C2 into R2 minus omega C1 into R1. Now we will write here that we can write as, let's take omega as common. What is inside the bracket? C2 into small r2 minus C1 into R1. Here from this equation, what is the value of this? So this is the value, C1 capital R1 minus C2 capital R2. Let's substitute this value here. Omega as it is. So inside the bracket C1 R1 minus C2 R2. Then now d2 minus d1, here also d2 minus d1, d2 minus d1. Now multiply omega c1 r1 minus omega c2 r2. Let's take omega c2 common. In here c1 r1 by r2. Here only r2 is there. Now here omega c2, c1 by c2, c1 by c2, what is there? c1 by c2 we can write it as r4 by r3, r4 by r3. So here c1 by, sorry, this is c2. Why? Because we had taken c2 as a common. So c1 by c2 is r4 by r3 into r1 minus r2. Now omega c2 as it is. So let's write the equation as r1 r4 by r3 minus r2. So this is the dissipation function of the modified de-Sauty's bridge. Now we will discuss about the phase